We're always chasing the new, shiny thing in tech, right? Well, what if I told you that one of the most important pieces of software running our world today is from 1986? It's not just hanging on, it's actually thriving. It's behind the scenes at huge banks and hospitals, all these mission-critical places. And yet, most people have never even heard of it. So today, we're going to pull back the curtain on this unsung hero, IBM AIX.
All right, let's just cut to the chase. Why on earth should we be talking about a 40-year-old operating system today? I mean, tech gets old in, 5 years? The reason is, it all boils down to this one single metric, something so important that big companies will pay a ton of money for it.
I mean, really, just stop and think about this for a second. What if your system just never went down? If you're a bank and your systems are down, you're not just annoying customers, you're losing millions of dollars every single minute. If you're a hospital, downtime could literally be a matter of life and death. And that is the exact problem AIX was built to solve from day one, to create a system that is so reliable, it's basically always on.
And here it is. This number is everything. 99.9999%. We call it 6 nines uptime. Let that sink in for a moment. We're talking about a system being down for a maximum of 31 seconds in an entire year. To give you some perspective, a lot of companies strive for 5 nines, and that's considered great, but that's still over 5 minutes of downtime a year. 6 nines is a whole other level. It's the absolute gold standard, and it's exactly why AIX is still the king in places like banking, healthcare, and government. Okay, so now we get why it's so important. That reliability is everything. But the story of how IAX became this rock-solid OS? Oh, it's a wild ride. It's got some twists and turns you would just not expect.
So check this out. The thing that's so wild about AIX's history is just how adaptable it was. It wasn't built for just one kind of computer. Nope. It started out on this early RISC workstation from IBM, then it hopped over to good old personal computers, and eventually, it found its true home on IBM's Power architecture. But here's the kicker, and you might want to sit down for this. For a little while, it was the OS running on servers made by Apple. Seriously, that Apple.
And that right there is the really amazing part. You think of an OS like this and you picture giant lockdown server rooms, right? But back in the day, that wasn't the whole story. For a little bit, you could get AIX running on an IBM PS2, a computer you might have had on your desk at work or even at home. It ran on the legendary System/370 mainframes too. I mean, this operating system has been everywhere. So after this period of, let's call it finding itself, AIX finally settled down. It found its perfect match with IBM's own Power processors. And this partnership, this is what turned AIX from just another flexible Unix into an absolute legend of reliability. And it was all thanks to a few groundbreaking ideas. Okay, so one of the first huge innovations, and AIX was actually the pioneer here, was something called the journaling file system. Here's the simple version. Imagine you're writing in a notebook. Instead of just erasing and rewriting, you first make a little note in the margin saying, I'm about to change this sentence. That's kind of what JFS does. It logs the change before it makes it. So if the system suddenly crashes, power goes out or something, it doesn't have to read the entire notebook to figure out where it left off. It just looks at that last note. This made rebooting after a crash incredibly fast. It was a total game changer. And they didn't just stop there, not at all. AIX got a ton of its good genes, you could say, from IBM's super dependable mainframes. It brought over things like the Logical Volume Manager, or LVM. This thing lets you change the size of your disk storage while the system was still running. I mean, that was basically science fiction back then. You add in some really helpful admin tools like SMIT, and boom, you've got an OS that's not just stable, but also way easier to manage. So, that's the foundation. IX built this reputation for being an absolute tank decades ago. But the big question is, how does that hold up today? Let's take a look at how those core ideas from the past have evolved into the features that make IX a monster in the modern data center.
I mean, just look at this comparison. It really shows you the journey. We're talking about an OS that used to install from like 8 floppy disks onto a pretty basic workstation. Today, that same OS is managing massive systems with 256 cores and over 1,000 threads of execution. It's gone from being a single box in a corner to being the engine for huge hybrid clouds. It talks to AI, it works with containers. It's a completely different beast.
So how in the world does it actually do it? How does it hit that near-zero downtime number? Well, it's not magic. It's just some seriously clever engineering, stacked one layer on top of another.
For starters, it can wall off applications in these things called WPARs, which are a lot like the containers we use today. Then, and this is wild, it can move a whole running system, applications, memory, everything, from one physical server to another without anyone noticing. No interruption. And the craziest part, it can update its own brain, the kernel, while it's running. No reboot needed. That is how you get to 6 nines.
And holding this all together underneath is this key piece called the Object Data Manager, or ODM. Now, the best analogy for it is probably the Windows registry. It's one central database that keeps track of every single system setting and device configuration. Everything's in one place. This makes the whole system super predictable and consistent, which, when you're managing huge, important systems, is exactly what you want.
All right, so we've established it's reliable. It's a tank. Nobody's arguing with that. But let's be real. It's 40 years old. In the tech world, that's ancient. So is AIX just a cool piece of history, a relic? Or is it actually built for what's coming next? Well, first things first, let's get one thing straight. AIX is not abandonware. It's not just sitting there frozen in 1986. I mean, just look at the timeline of its major versions. This thing is constantly being updated and improved. As older versions get retired, new, fully supported ones are ready to go. It's very much a living, breathing OS.
And if you're still not convinced, check this out. This is the ultimate proof. IBM has a public roadmap for AIX, and that roadmap goes all the way out to 2035 and beyond. They are actively planning for it to run on processors like the Power 11, which haven't even been invented yet. That's not just keeping the lights on, that is a serious long-term commitment.
And that future roadmap isn't just about more of the same. No way. AIX is plugging itself directly into the tech that's defining the future. We're talking deep integration with hybrid cloud stuff like Red Hat OpenShift. It's being optimized for the massive demands of AI. It even has security features being built in to protect against quantum computers down the road. So yeah, this OS isn't retiring, it's retooling. And that kind of brings us full circle, doesn't it? Our industry is obsessed with disruption, with moving fast and breaking things, always chasing the next big thing. But AIX, it stands for something else entirely. It's about stability, resilience, building something for the long haul. Which leaves us with a pretty interesting question to think about. In this constant rush for what's new, have we maybe lost sight of the incredible value of technology that's just built to last?